Hey guys, we are going to go over problems 2, 3, and 4 from the last worksheet that you guys did on inverses. And we are also going to talk about composing functions. So let's start. Number 2, you guys had on your worksheet this h of x, and it was equal to the square root of 2x plus 1. Okay, that's what you had on your sheet. So first of all, we'll start by finding the inverse. So remember, you take this and you switch it to y. That's the first thing you want to do. And I don't really need these parentheses because I know, again, that this whole thing is underneath the square root. So that whole thing is still underneath there. So y equals that. And now, remember, now switch x and y. So we're going to say x equals the square root of negative 2y plus 1. And now you're going to have to solve for y. Okay? So we want to get this y by itself. First of all, this right here is a problem, this square root. So if you remember, a square, like to square something, undoes a square root. So if you square both sides, meaning use that little 2 as an exponent, that squares both sides, then the square root and the square undo each other, and you end up with, on the left side, you have x squared, and on the right side, you have negative 2y plus 1. Then after that, you have to, again, get y by itself. So we need to get rid of this 1 first, this plus 1. What's the opposite of that? Minus 1. We have to subtract 1 from both sides. Okay, so we end up getting, these can't be combined, so we end up getting x squared minus 1 equals, and then again, those two ended up canceling out their opposites, so we have negative 2y. And then the very final thing to solve for y is to divide both sides of the equal sign by negative 2. Okay, notice here's the equal sign. So you're dividing both sides by negative 2. So you kind of look at it like a fraction. You draw a little bar under both sides, and then you put the negative 2 underneath that. So those cancel out, and you end up with a y, 1y on the right, and on the left side we have this. Oops, x squared, minus 1 over negative 2. All right, so there's our inverse, and then the final thing, I'm going to flip this around, and instead of the y, I'm going to go back up here and say h prime of x, meaning it's the inverse of x. And that's x squared minus 1 over negative 2. Okay? And if you were to graph these, like I said, you would end up with something that looks maybe, you know, like if this was, if this looked like this, for instance, okay? If that was that function, square root, then you would end up reflecting it over this line. This line is the y equals x line. Okay, so you would reflect it, so it would kind of do this. So that would be the graph of your inverse. Okay? So that's just kind of an interesting thing. Now, I think this actually might be flipped over, but the general idea is if it looked like this, it would be reflected over this line. I actually think this ends up being flipped a different way, but we can graph that to confirm it. So anyway, so now here's the composing part that I wanted to show you today. If you plug in your inverse back into your original function, you're actually going to end up, things are going to cancel out. You should get everything canceled out except for x. Once you plug everything in and simplify, you should just get an x. Okay? So I just want to show you an example of that, and then we'll do the other two. So if I were to plug in my inverse into the original, here's my original function. There's my original function. If I plug in the inverse into this in place of x, so I've got to plug all of this into that. All right, plug all of that, the inverse, what the inverse equals, into the place of x. So I'm going to do the square root of -2 times, let's put in our inverse now. Instead of x, we're going to put in our inverse. So we're going to put in x squared minus 1 over -2. And then don't forget, we put it in for x, but we still have this plus 1 over here. So we got to say plus 1. And so now we can simplify this thing. Okay, so I'm plugging in, this right here is h of not just x, this time I'm plugging in my inverse into the h function, basically. That's what I'm doing. Here's my inverse, I'm putting it into the h function in place of x. That's what I'm doing. So now I can simplify this thing. So if you notice, the -2 and the -2, they end up canceling. One's on top, one's on bottom. So I end up with, what's left is x squared minus 1. Then now we have this plus 1 over here. Now the -1 and the +1 also cancel out. So then we end up with the square root of x squared. And what's the square root of x squared? Well, x times x is x squared. So the square root of x squared, remember, they undo each other. So we end up with x. And that's good. That means I found the correct inverse. If I get an x when I plug in the inverse into the original function and I get an x, that means yes, they are inverses indeed. So now we're going to do number 3, because I know you guys had a little bit of trouble with number 3 as well. So we're going to do number 3 from your worksheet. So here is p of x, and it's equal to the square root of 3x, and then outside of the square root is a -12. Okay, it's not underneath the square root. Many of you guys, I think, thought it was, but you actually, you know, just this 3x is underneath this square root. And so remember, start off by saying y equals the square root of 3x minus 12. And then remember, we flip-flop the x and the y. So we say x equals the square root of 3y minus 12. And then I think this might have been another problem maybe that you guys had. You guys wanted to square this right away, but you can't. You have this minus 12 over here. So you have to start by adding 12 to both sides. So add 12 to both sides. All right, and then you end up getting x plus 12 on the left, because those are not like terms. And you get the square root of 3y over here. We can cross these out. So we're almost done. Now that we have the square root part by itself, now we are allowed to square both sides. So we square both sides, okay, we put parentheses around each side, and we put a little 2 as an exponent. And remember, the square root and the square, they undo each other. So this you do not have to simplify. You can leave it just like that. And now we have a 3y on the right side. The last step is to divide by 3. Divide by 3. So now we have, again, y, x plus 12 squared over 3 equals y. And then always, at the very end, just go back up to the top and notice this was p of x originally. So instead of this y, I'm going to say, I'm going to flip it back around too. Instead of the y, though, I'm going to say p prime of x, the inverse, basically. equals, and then I'm going to put this over here. So I'll just do that, just so you can see what I did here. X plus 12 squared over 3. And there's that. Now again, what I want you to do today is try plugging this right here, try plugging this back into this right here, back into this function here. So what you're going to do, like I said, you're going to try to say, okay, p of x equals square root 3x minus 12. That's the original function. You're going to put in all of this in place of this x here and try to simplify it and see if you get x. You should get x, but just maybe show me how you did that. So you would say p of, instead of x, we're going to plug in what the inverse is. So inverse of x. And again, that just means you're going to say 3 times, and instead of x, we're going to put in this stuff right here. So I might have to extend this a little bit more. So x plus 12 squared over 3. That all goes underneath this square root. And then we have a minus 12 outside of it. So see, when you simplify this, see what cancels and see if you get just an x at the end. Last one. All right, so number 4. Definitely needed to go over that. So number 4 was m of x equals 7 times x plus 2 squared minus 1. All right, so I'm going to, again, try to get the inverse here. So I say y equals 7 x plus 2 squared minus 1. Then I flip-flop x and y, right? So I say x equals 7 times y plus 2 squared minus 1. And then I start solving for y. So notice I need to get rid of this minus 1 first. Again, think opposite, like word of operations, but in reverse. So normally you would, if you were to look at y, you would normally do what's in parentheses, then you would multiply, or square, then multiply by 7, then subtract. You're going to go in reverse. Start with this. So add 1. Add 1. So when you do that, you get x plus 1 equals 7 times y plus 2 squared. Again, these cancel. Then, again, you want to do the next thing, which is using the 7 here. Okay? So divide by 7, because this is multiplied by 7. So you need to divide by 7. So 7 divided by 7 is 1, and so those cancel out. So now you have this, x plus 1 over 7 equals, and we have y plus 2 squared. Okay? And now you're allowed to undo the square root, which means take the square root. So opposite of a square is a square root. All right? And then remember, when I told you guys this last week, when you take a square root, you're actually getting plus or minus whatever this is. So we have plus or minus x plus 1 over 7. The square and the square root cancel. So you have y plus 2. And then the final step to get y by itself is subtract 2. Subtract 2. So you end up here with negative 2 plus or minus the square root of x plus 1 over 7 equals y. And then the very last step is to go back up here and say it's m inverse of x equals all of this. Negative 2 plus or minus the square root of x plus 1, x plus 1 over 7. And remember, we talked about this also last time. This is a quadratic function, and so we talked about limiting the domain so that we could get an inverse. Only one of these is going to end up being an inverse, either the negative 2 plus the square root of x plus 1 over 7, or negative 2 minus the square root of x plus 1 over 7, depending on which side you choose to be, your original function, what domain you choose. So if this ends up looking, the original function ends up kind of looking, it's left 2 and down 1. So it's kind of like this. And you just have to pick, being as this is not 1-to-1, meaning it doesn't pass the horizontal line test, you just have to pick one of the sides of this. So if you look right down the middle here, this is x equals negative 2. If you just look right down the middle of that, you can just decide, do I want to find the inverse of the left side of the graph or the right side of the graph? And so that'll depend too then, like if you pick the right side of the graph, then your inverse, remember it gets reflected along this line, your inverse is, going to be doing this. It's going to be the mirror image of this one right here. So it'll kind of be doing that. But if you pick this side, then you're basically, think about, again, this is your line here. It'll kind of look like this. It'll go down that way. So basically you just have to decide, like I said, which side to pick, and then when you find out your inverse, you can decide which one it is. But in general, this is how you find your inverses. And then if you plug this inverse back into the original function, you should get x when you simplify it. So try that as well.